Imagine looking out into the vastness of space. You see a planet, a giant in our solar system. This planet is Saturn. It wears a spectacular crown of light. These are its famous rings. They shimmer and shine, a breathtaking sight. These rings are not solid bands as they might appear from afar. Instead, they are made of countless small pieces. Billions, perhaps trillions of icy particles. These particles range greatly in size. Some are as tiny as grains of dust. Others are as large as a house or even a small mountain. All these icy chunks orbit Saturn together. They form a wide, flat disk, a cosmic ballet of ice and rocks swirling endlessly. The sheer scale of Saturn's rings is mind-boggling. They stretch out for hundreds of thousands of kilometers. Yet for all their incredible width, they are astonishingly thin. This delicate structure makes their existence even more wondrous. Our journey to understand Saturn's rings began long ago. In 1610, Galileo Galilei pointed his telescope to the heavens. He looked at Saturn, a distant point of light. What he saw was peculiar, unlike anything else. He didn't see rings as we know them today. His early telescope wasn't powerful enough for that. He thought Saturn might have ears, or perhaps two large moons flanking it. Galileo was puzzled by his observations. The image through his telescope was blurry and indistinct. He made drawings of what he thought were handles or appendages on either side of Saturn. He was even more confused when a couple of years later, these features seemed to disappear. Then, they reappeared again. This happened because Earth was passing through the plane of Saturn's rings. When viewed edge-on, the thin rings become nearly invisible from Earth. Galileo didn't know what to make of this cosmic vanishing act. It wasn't until 1655 that Christian Huygens proposed that Saturn was surrounded by a thin, flat ring. One of the biggest questions about Saturn's rings is, where did they come from? Scientists have proposed several theories to explain their origin. One leading theory suggests the rings are the remnants of a shattered celestial body. Imagine a moon, perhaps an icy one, orbiting Saturn long ago. Saturn's immense gravity would have exerted powerful tidal forces on it. If the moon crossed a certain boundary, called the Roche limit, these forces would overcome its own gravity. The moon would have been torn apart, ripped into countless pieces. These fragments would then spread out, forming the rings we see today. Another possibility is that the rings are made of primordial material. This theory suggests the rings formed from the same vast cloud of gas and dust that gave birth to Saturn and its moons. Recent evidence suggests the rings might be surprisingly young, perhaps only a few 100 million years old. Our understanding of Saturn's rings took a giant leap forward with the Cassini-Huygens mission. Cassini arrived at Saturn in 2004 and spent 13 incredible years studying the planet. It explored its moons, its magnetosphere, and of course, its magnificent rings. Cassini's instruments provided unprecedented details about the rings' composition and structure. It confirmed that the rings are overwhelmingly made of water ice. The spacecraft revealed intricate patterns within the rings, waves, ripples, and even propeller-like features. These structures are created by the gravitational influence of Saturn's many small moons. Some tiny moonlets, called shepherd moons, were found embedded within the rings themselves. They helped to sculpt the rings' edges and maintain their shape. One of the most surprising discoveries from Cassini was the phenomenon of ring rain. The spacecraft found that material from the rings is constantly falling into Saturn's upper atmosphere. Tiny icy particles, charged by sunlight or micrometeoroid impacts, are pulled along Saturn's magnetic field lines. They then rain down onto the planet, primarily at mid-latitudes. This means the rings are not static or permanent features. They are slowly eroding, losing mass over time. Saturn's rings are far more than just a beautiful spectacle in the night sky. They serve as a unique natural laboratory right in our cosmic neighborhood. By studying the complex interactions of the countless particles within the rings, we learn. We learn about the fundamental processes that govern how planetary systems form and evolve. The way these icy particles clump together, collide, and spread out mirrors early solar system dynamics. It's like watching a miniature version of planet formation in action. This helps us understand how planets like Earth gathered material billions of years ago. The rings also provide a stunning demonstration of gravitational forces at work. We can observe how Saturn's gravity shapes the rings into their flat, disc-like structure. We see how the tiny shepherd moons carve out gaps and create sharp edges. They generate intricate wave patterns that ripple through the ring material. Understanding these gravitational dances helps us interpret observations of other disk systems. For example, protoplanetary disks around young stars where new planets are being born. The lessons learned at Saturn can be applied across the cosmos. Ultimately, the study of Saturn's rings fuels our innate human curiosity and inspires us to explore.